Today we're going to discuss the topic constructional features of three-phase induction motor in the subject of design of electrical machines. The three-phase induction motor basically consists of stator and rotor. This is part 1 of the total construction discussion, where I'll be discussing the construction of the stator. In part 2, the rotor construction will be discussed. The rotor basically are of two types, squirrel cage type and slip ring type. This will be discussed in part 2 of the video. This is the explosion view of the three-phase induction motor. We're talking about squirrel cage induction motor. As far as industries are concerned, more than 90 to 95% of the motor used in industry are of squirrel cage three-phase induction motor type. Here we can see the different parts of the induction motor in an exploded view. We have here the back cover of the motor. Then this is also known as the fan cover, which protects the fan rotating for cooling purpose. The fan will be either forced draught fan or it could be an induced draught fan. Generally, force type of ventilation system is used. Then there is the end cover, and this is the main frame of the motor, which consists of the conduit box, which is provided for the connections to the supply system. So the winding terminals are brought out onto this terminal box, which can be connected to the three-phase AC supply. The windings are of copper of a three-phase system. Then we have got the rotor, which is a squirrel cage type. At both the ends of the shaft, bearings are provided, and then again end seal is there. So for the winding, I want to specifically mention here that we can see only the overhang here. The active part of the conductor will be inside the stator core. So basically this is the overall construction of the motor. In this first part we will be discussing only the construction of the stator. The stator of three-phase induction motor consists of stator frame, stator core and stator slot. The stator frame is the outermost part of the motor. It provides a support and protection to the core as well as the winding. The winding being the most delicate part of the motor, because it is made up of copper, and copper is very soft in nature, so we must provide sufficient protection to the winding. It also provides shielding to the human being from the live parts of the motor, so protection is provided to the human being or surrounding. It also provides a path for the cooling medium for effective cooling, so air ventilation is required to be there so that the motor remains within its limited temperature range. So fan will be providing the cooling, but stator frame consists of the axial ventilating ducts, or it may have a radial ventilating ducts. So these ducts will be having flow of air through it. So the stator frame provides sufficient path for this particular flow of air. The stator frame is basically made up of cast iron. So it is dyed using cast iron, or it can be made up of mild steel with fabrication, either riveted or welded. For large size motor we are using fabrications, whereas for small motors a single casting of iron will be sufficient for the frame. The frame also has to be very rigid because if you can see, the weight of the motor, or specifically the rotor, is high. So due to its natural sagging nature, the air gap in the motor remains less at the lower side as compared to the higher side. This leads to what is known as the unbalanced magnetic pull. So the magnetic field will be different on the upper side of the motor as compared to the lower side. So the frame has to be rigid so that this particular unbalanced magnetic pull is minimized. So the stator frame basically is also decided or depends upon the working environment in which that particular motor is to be used. If the motor is, let's say, used in chemical plants, then these chemical fumes may affect this winding, and a short circuit may occur and it may lead to an explosion. So over there we need a frame which is totally explosion proof type. So this motor over here shows an explosion proof type motor. So frame is totally strong enough to avoid that particular type of accidents. Nowadays, we know for irrigation purposes, we use submersible type of pumps. So if three-phase induction motors are used for these pumps, then that frame has to be such that no leakage of water should be there as far as motor is concerned, otherwise that motor will fail. So the frame plays a very important role in protecting the motor from the environmental conditions in which it is placed. Usually, totally enclosed type of frame is used, and when we are saying totally enclosed, then definitely the amount of air which is required for cooling will not be sufficient. So, in order to have better cooling, we use axial fins on the surface of the induction motor. So induction motor is generally, if you observe it with your naked eyes, you will it is distinct with axial fins. So you can identify that this is a induction type of motor with whenever you see an axial fins. So this is just a general thumb rule for identifying either it is a AC type of motor or a DC motor, whereas DC motor will have a smooth surface. So that stator core is made up of laminated silicon steel, where the laminations will be having a thickness of 0.7 to 0.35 mm to reduce the eddy current loss. And to reduce the hysteresis loss, the steel is added with 3 to 5% of silicon to get the best property. Of course, there are two types of processes in which these laminations are manufactured. Either you can have a hot processed, known as hot rolled grain oriented silicon steel, or you can have a cold process for manufacturing, known as cold rolled grain oriented silicon steel. So usually we use CRGO material, which is also known as the diamond grade type of laminations. So we use laminated silicon steel to reduce the iron loss, so total iron loss will be reduced. This stator core is supported and protected by the stator frame. So there are dovetail type of slots are provided in which these all laminations are slided, and at the end they are bolted and not bolted together tightly to form the stator core. There are slots in the inner periphery. These slots are provided to carry the three-phase armature winding. So these slots are always in the multiples of 3 into 2, 3 being the for three-phase and 2 is the number of poles. So poles are always in even numbers. So these slots are always in the multiples of 6. So the stator core basically for large size motors is in segments, and this segment may have a length anywhere from 0.3 meter to 0.6 meters. If the motor frame is very large, then we may have core in different segments, and then these segments will be connected together, and at the end on both the sides they will be tightly connected by nuts and bolts, and rod will be inserted into them, and at both ends they will be tightened. So for large type of motor, these segments are used, maybe 4, 6 depending upon the size. Besides the segments, the motor is required to have effective cooling. For that, there is a thumb rule that for every 100-meter length of the stator core, there will be a radial ventilating duct of 8 to 10 mm is provided for cooling purpose, both as in the stator core as well as in the rotor core. So the air can easily flow in and out of the core and maintain the temperature within its permissible limit. So the overall length of the core in that case will increase, and we will discuss in our coming lectures that how this duct will affect the performance of this particular induction motor. The stator slots which are there in the inner periphery of the stator core are provided for carrying the three-phase winding, which is wound with the copper conductors. They can have any of these shapes. The slots can be either tapered, rectangular type of slots, or circular type of slots. Generally, for circular conductors, tapered type of slots provide effective characteristics, because tapered slot means a large number of conductors in the end as compared to on the surface. So the starting characteristic as well as the running characteristics of the motor will improve with the taper slots. Then, as far as the types are concerned, the slots can either be semi-enclosed type or they can be totally closed type of slots. For very small motors, closed type of slots are used, but for large size or medium size motor, semi-enclosed type of slots are used, where winding is wound on the former on outside, and then they are placed in this particular slots. The time saving occurs and the cost of the motor reduces. So for very small motors where the number of conductors are less, we can use closed type of slots. As far as the winding is concerned, the stator winding are provided in the stator slots. They are multiples of 6, as I already told. Each slot has an insulation between the slot and the winding. So winding will be at some voltage as far as supply voltage is concerned, whereas the stator core will be at zero potential. So there has to be a insulation level maintained between the slot and the winding. So generally the Nomex paper are used for this particular insulation purposes. Papers, different types are also available. Thank you, friends. That's as far as the stator construction is concerned. If you like the video, kindly give your comments, to share and subscribe to my channel.